So today we are going to discuss the third problem of Leetcode Weekly Contest 284, which is maximize the topmost element after k moves. So we are given a stack of some elements, n elements, and we can either remove the top element of the pile, or we can add some of the elements which we are already removed in the pile. We can do exactly k moves, and we have to figure out what is the maximum element which can be our top element after k moves is done. So let us take the first example, 522406. Let us take the first example, which is I think 522406 40 and 6. So and what is the number of moves we can make? Our k is equal to 4, so the number of moves we can make is 4. So let's say what will be the possible ways we can remove the elements to get the desired element. So our answer is 5 here. Why? How can we can achieve 5 is that, so first we will remove 5 from here. Let's say let me write this once again, 522406. So how we can get 5 from here? Let us figure it out. So first we will remove 5, then we will remove 1, then we will remove 2, then we will put back 5. So our top element will be 5, and we have made 4 moves. So what is the first observation which you can make from this problem? So the first observation you can make is that if k equals to 0, then what will be our answer? So let's say if k equals to 0, then our answer should be the top element of the current list. So if k equals to 0, our answer should be 5. For any case, our answer should be now 0 for k equals to 0. And for k equals to 1, what will be our answer? So for k equals to 1, our answer should be nums 1. Okay, this element. Okay, for k equals to 1, answer should be always the second top element. Okay, the second element from the top. Okay, and another case. Now these are two like extra case, edge cases, and another case is when n equals to 1. So this is the case where I think someone got trouble. I got trouble in this case. If n equals to 1, let's say our element is x, so we have to remove first x from the like if k is odd, then we'll remove x from the list, and k is even, we are putting x into the list. So if k is odd, then our answer should be -1. Our answer should be -1, and if k is even, our answer should be top element. Okay, so here are three edge cases which you have to cover. These three are like quite intuitive and quite easy to figure it out, but if you have missed some of these, then you may got into trouble. Okay, so these are the edge cases. So after the edge cases are done, the problem is quite simple and quite easy, quite straightforward. So what will be our approach? Like let's say what could be our possible values. So any element from the top k minus 1 element, so let's say k equals to 4, so any of these three elements could be our top, because we will remove this k minus 1 elements, from the list, and we can put back any of these k minus 1 elements. Okay, so any element from the top k minus 1 element could be our answer. Okay, and another one case is that our kth element, like our k plus I mean k plus 1th element, which is here fifth element, could be our answer, because we have removed 5, 2, 2 and 4. If we remove all the 4 elements, then 0 will be our answer. Okay, so our answer could be maximum of any element from nums, like we can name it as pile. So our element could be any element from pile 0 to k minus 1 element, or another element will be pile of k. Okay, so these two could be our possibilities. We have to take max of these two. Okay, so we have to take this and this and take the max. So another one edge case could be added here, which is if k greater than n. So if k greater than equals to n, here could be another edge case. So if k equals to n, if k equals to n, then we can do it like this way. So let's say uh, if k is only greater than n, then that would be our edge case. So let me remove this greater than equal to sign. So if k is greater than n, then what will be our answer? So if k is greater than n, we can take the maximum element of this, and that would be our answer. So if k greater than n, we have to find the maximum of pile. If k less than equal to n, we can try out with this formula. Okay. So this is quite straightforward. I can show you my code. Like So if n is odd and k is odd, sorry, if n is 1 and k is odd, then we will return -1, else we will return the top element. If k equals to 0, we will return the top element, and if k equals to 1, we will return the second top element. And else we are figuring out the minimum maximum from the top k minus 1 element. Here you have to take minimum of n comma k minus 1, else it could look up to k, and it would give you like index out of bound error. So if k less than n, we are taking out maximum of max comma ak, whoever which I have mentioned. Here is the case, and at the end we are returning the maximum. Okay. I hope you have understood my video. If you have liked the video, please like the video and subscribe to my channel. And if you have any query, you can ask in the comment section. Thank you.